Okay, now let's make another truth table. What if I tell you, make a truth table for this, not P and not Q. Okay, now, here are the 4 possibilities. If P is true, true, false, false, what do you think not P is? What's the opposite of true, true, false, false? False, false, true, true. If Q is true, false, what do you think not Q is going to be? False, true, false, true. Okay, now you got these 2 statements and we're connecting them with AND. When is the AND statement true? We just did this 3 minutes ago. When both of them are true. Are both of them true? Are both of them true? Good. Good. What? Yes, they are. And there you go. So this represents this. There you go. Okay, now tell me, what did we learn from that? This is how homework works in this class. We just learned something.
It's the same.
It's the same! Hey, this truth table is false, 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 true. This one is false, 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 true. So that must mean these 2 statements are... If 2 statements have exactly the same truth table, we say that these statements are... Now some of you want to say equal. See, but the thing is, see, only numbers can be equal. See, like 1 plus 2 equal 3. These are numbers. But now these are statements, so we cannot say they're equal. We see that this is in the notes, people. These are logically equivalent. See how it looks like an equal sign? But it's not an equal sign. That's because these aren't numbers, these are statements. But it has the same meaning. So if 2 statements have exactly the same truth table, that means they are logically equivalent. That means we can replace one with the other. In fact, this is a very famous one in logic. This is called De Morgan's law, named after the mathematician Augustus De Morgan. Oh, so Mr. Park, this kind of reminds me of the distributive property. I can distribute a negation sign to an OR statement. All I have to do is change the OR to AND. Yeah, so these are the kinds of patterns, and these are all in the notes. You have to know. You gotta have it in the palm of your hand. You guys get it? You can actually distribute the negation sign, except you gotta change the OR to AND. Okay, now, in the later problems, Mr. Park, I noticed that there's 3 statements, P, Q, and R. Now, if you have 3 statements, P, Q, and R, how many possibilities are there going to be now? 9. Where do you get 9 from? Look, P is either true or false. There's 2 choices. Q has 2 choices, either true or false. R has 2 choices. What does the multiplication principle tell us? 2 times 2 times 2 is 9. No, it's 8. There's going to be 8 lines in the truth table. So when you do your homework, you might want to do it on folder paper because then you get the lines, but it doesn't matter. Okay, so what's the standard way of doing it? True, 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 false, 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 false. Then in the next one, what do you think? True, true, false, false, true, true, false, false. And then in the third line, what do you think? True, false, true, false, true, false, true, false. And there you go. That's the standard way of doing it. Oh, I see a pattern. Yes, the one on the right-hand side always alternates by 1s. Then this one is going to alternate by 2. This one alternates by 4, and so forth. So if you had another one, what would this one do? It would alternate by 8. Okay, now let me just give you a preview for the test. I remember one year I gave this problem. You had P, Q, R, S, T, U, V, W, X, Y, Z. Yeah. Okay, now, so how many lines would there be in the truth table if you were to make it? Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11. So 2 times 2 times 2, 11 times is 2 to the 11th. Which is? Now we all know common knowledge, 2 to the 10th is 1024. That's a number you should know. So therefore 2 to the 11th is 2048. Okay, there are 2048 lines in this truth table. Now I'm not going to make you write out all 2048 lines. That's just dumb. Okay, but what are you guys, class of 2000? Okay. In the 2015th line, fill in all the values.
Just kidding, we're at class of 1.
What?
We're at class of 1.
But you're not the class of 1. Come on, think about it. Okay, in the last column, it's true, false. It alternates by 1, right? True, false, true, false, true, false, true, false. So when you get to the 2015 one, what do you think it is? Look, 1, 2, 3, 4. All the odd ones are true, the even ones are falses. Come on. Is 2015 odd or even? Okay, so therefore? Okay, it's true. Okay, and then the 1, and then of course this one alternates by 2s, and it alternates by 4s, 8s, 16. Okay, all the way till you get here. So what's the one over here going to do? You're going to have 1,024 trues, and then you're going to have 1,024 falses. So where do you think that falls? That's false. See, you guys can figure it out. I'll do other ones in between. That's the way I think. That's the way I write problems. I'm just trying to help you out here. You don't want to be shocked right into oblivion. Or maybe you do, I don't know. So the main thing, see, that's what some of you got to get used to. When you do homework, that's when you learn mathematics. That's when you learn it, when you do the homework. Although some of you, what do? I'm just going to copy somebody's homework and then take the test, and then that's when I'm going to learn. No, yeah, you could. You probably, that might work sometimes, but when you do your homework, that's when you learn. You know what I'm talking about? That's why homework is important, to reinforce, to be able to apply something you learned to a new situation. Oh my gosh, that was almost an hour. That's ridiculous. Okay, this class ends at? I thought we were going to end like at 10, or maybe even 10, and then you would have the rest of the time to finish your homework before you even leave this class. But that didn't happen. Okay, we're done. I'm curious how long this video is.